Hello everyone, welcome to our class. My name is Ko Chen Lee. In today's sections, we will talk about boot configurations and storage management. This is today's outline. We will show you the introductions, boot from hardware and firmware, boot environment essentials, and managing startup and boot configurations. Unlike earlier releases of server operating systems for Windows, Windows Server 2008 doesn't boot from an initialization file. Instead, the operating system uses the Windows Boot Manager to initialize and start the operating system. The boot environment dramatically changes the way operating systems starts and is designed to resolve issues related to boot integrity, operating system integrities, and firmware abstractions. The boot environment is loaded prior to the operating systems, making it a pre-operating system environment. This ensures that the boot environment can be used to validate the integrity of the startup process and the operating system itself before actually starting the operating systems. At first glance, startup and shutdown seems to be the most basic features of an operating system. But as you get a better understanding of how computers work, you quickly see that there's nothing simple or basic about startup, shutdowns, or related processes and procedures. Problems with startup and shutdowns are compounded in Windows Vista and Windows Server 2008 because of their extended frameworks for advanced configurations and power management in firmware and hardware. For hardware and the firmware power states, before the boot environment is loaded, computers start out from hardware and firmware. Turning off a computer and shutting down a computer are separate tasks. When entering standby mode, the operating system automatically saved all work. Turn off the display and enter a low power consumption mode with the computer's fans and hard disk stopped. The state of the computer is maintained in the computer's memory. When the computers wake up from standby mode, its state is exactly as it was when you turn off your computer. And you can turn off a computer's running and enter standby mode by clicking the start button and then clicking the power button. To wake the computer from the standby state, you can press the power buttons on the computer's case or a key on the computer's keyboard. Moving the mouse also wakes the computer. And mobile computers running Windows OS can be turned off and turned on by closing or opening the lid. When you close the lid, the laptop enters the standby state. When you open the lid, the laptop wakes up from the standby state. There are, however, a few gotchas with the power buttons and the standby states in Windows OS. The way the power button works depends on the following. System hardware. For the power button to work, the computer hardware must support the standby state. System state. For the power button to work, the system must be in a valid state. If the computer has installed updates that require reboot, or you have installed programs that requires a reboot, the computers cannot enter the standby state, and turning off the computer powers is done completely. The system configurations. For the power button to work, sleep mode must be enabled. If you have reconfigured the power options on the computers and set the power buttons to the shutdown actions, the computer cannot use the standby state, and turning off the computer powers is done completely. And amber power buttons depicting a shield with a line through the top of it indicates that the computer will turn off and enter low power sleep state. A red power button depicting a shield with a line in the middle of it indicates that the computer will shut down and completely powered off. Diagnosing hardware and firmware startup problems. When you are working with Windows Vista or Windows Server 2008 and trying to diagnose and resolve startup problems, it's important to remember that power state management capabilities are provided by the hardware but are enabled by the operating systems. Because of this, to fully diagnose and resolve problems boot issues, you must look at the computer hardware and software, including motherboard, chipset, firmware, operating systems. To better understand the hardware aspects related to boot issues, let's dig in and take a look at advanced configurations and power interface, ACPI. A computer motherboard chipset, firmware, and operating systems must support ACPI for the advanced power state features to work. There are many different types of motherboard chipsets. Although older motherboard chipsets might not be updatable, most of the new ones have updatable firmware. Chipset firmware is separate from the computer's underlying firmware interface. Currently, the two prevalent firmware interfaces are basic input-output system, BIOS, extensible firmware interface, EFI. A computer's BIOS or EFI programming provides the hardware-level interface between hardware components and software. Like chipsets themselves, BIOS and EFI can be updated. ACPI-aware components track the power state of the computers. And ACPI-aware operating systems can generate a request let the system be switched into different ACPI mode. BIOS or EFI responds to enable the request ACPI mode. As shown in tables, There are a total of 6 different power states ranging from S0, the system is completely powered on and fully operational, to S5, the system is completely powered off. And the states S1, S2, S3, and S4 are referred to as sleep states, in which the system appears off because of low power consumptions and return enough of hardware contacts to return to the working state without a system reboot. Motherboards, chipsets suppose specific power states. For example, the Intel server board suppose S0, S1, S4, and S5 states, but does not support the S2 and S3 states. In Windows operating systems, the sleep power transition refers to switching off the system to a sleep or a hibernate mode. And the wake power transitions refers to switching on the system from a sleep or hibernate mode. The sleep and hibernate modes allow users to switch off and switch on systems much faster than regular shutdown and startup processes. Thus, a computer is waking up when the computer is transitioning from the off state S5 or any sleep state S1 to S4 to the on state S0, and the computer is going to sleep when the computer is transitioning from the on state S0 to the off state S5 or sleep state S1 to S4. So a computer cannot enter one sleep mode directly from another, as it must enter the on state before entering any other sleep state. Resolving hardware and firmware startup problems on most computers. You can enter the BIOS or EFI during boot by pressing F2 or any other function key. When you are in firmware, you can go to the power screens or similar screens to manage ACPI and related settings. Power settings you might see include after power failures or AC recovery, determines the mode of operations if a power loss occurs, and for which you see settings like state off, least state, least power on, power on. State off means the system will remain off after power is restored. Last state restores the system to the state it was in before power failed. Power on means the system will turn on after power is restored. Wake up length from S5 or auto power on determines the action taken when the system power is off and the PCI power management wake event occurs. You will see settings like state off or power on. ACPI suspend state or suspend mode sets the suspend mode. Typically, you will be able to set S1 state or S3 state as the suspend mode. Note that I provide 2 standard labels for each settings because your computer hardware may not have these exact labels. The firmware variant you are working with determines the actual labels that are associated with boot, power, and other settings. Because Intel and AMD also have other technologies to help reduce startup and resume times. You might also see power settings for enhanced Intel speed state technology, EIST, which can be either disabled or enabled Intel Quick Resume Technology Driver, QRTD, which can either disable or enable. Enhanced Intel SpeedStat technology, EIST or SpeedStat, allows the system to dynamically adjust processor's voltage and core frequency, which can result in decreasing average power consumptions and decrease average heat production. When EIST or a similar technology is enabled and in use, you will see two different processor speeds on the system page in control panel. The first speed list is the specified speed of the processors. The second speed is the current operating speed, which should be less than the first speed. If enhanced Intel SpeedStat technology is off, then both processor speeds will be equal. Advanced settings for power options under processors. Power management can also affect how this technology works. Generally speaking, although you might want to use this technology with Windows Vista 07, you want to use this technology with Windows Server 2008. Intel Quick Resume Technology Driver, QRTD, allows an Intel technology-based computer to behave like a consumer electronic device with instant on-off after an initial boot. Intel QRTD manages this behavior through the Quick Resume Mode function of the Intel V chipset. Pressing the power button on the computers or a remote control puts the computers in a quick sleep state. And you can switch the computer to the quick resume state by moving the mouse, pressing an on-off key on the keyboard if available, or pressing the sleep button on the remote control. Quick sleep mode is different from standard sleep mode. In quick sleep mode, the computer's video card stops sending data to the display. The sound is muted, and the monitor LED indicates a lowered power state on the monitors, but the power continues to be supplied to vital components on the systems, such as the processors, fans, and so on. As this technology was originally designed for Windows XP Media Center editions, in many cases, it does not work with the Windows Vista or generally should not be used with Windows Server 2008. You might need to disable these features in firmware to allow Windows Vista to properly sleep and resume. After you look at the computer's power settings in firmware, you should also review the computer's boot setting in firmware. Typically, you will be able to configure the following boot setting. Boot drive order. Determine the boot order for fixed disks. Boot to hard disk drive. Determines whether the computers can boot to fixed disk and can be set to disable or enable boot to removable devices. Determines whether the computers can boot to removable media and can be set to disable or enable and boot to network. Determine whether the computer can perform a network boot and can be set to disable or enable USB boot. determines whether the computers can boot to USB flash drive devices and can be set to disable or enabled. As with power settings, your computer might not have these exact labels, but labels should be similar. You will need to optimize these settings for the way you plan to use the computer. In most cases, with server's hardware, you will only want to enable boot to hard disk drive. The exceptions is for when you use BitLocker drive encryptions with BitLockers. You will want to enable boot to removable devices, USB boot, or both to ensure that the computer can detect USB flash drive with the encryption key during the boot process. Boot environment essentials. Windows Server 2008 supports several different processor architectures and several different disk partitioning styles. Generally, computers with x86-based and x64-based processors use the master boot records MBR disk partitioning style and BIOS. Computers with x64-based processors use the GUID partition table GPT disk partitioning style and intensible firmware interface EFI. BIOS and EFI currently are the two most prevalent firmware interfaces. With earlier releases of the server operating system for Windows, BIOS-based computers use NT-loader, NTLDRs, and boot.ini to boot into the operating system. NTLDR handles the task of loading the operating system, while boot.ini contains the parameters that enable startup, including identity of the boot partitions. Through boot.ini parameters, you can add options that control the ways the operating system starts, the way computer components are used, and the way operating system features are used. And Windows Server 2008 doesn't use these boot facilities. Instead, they use a pre-operating system boot environment. Figure provides a conceptual overview of how the boot environment fits into the overall computer architectures. The boot environment is an extensible abstraction layer that allows the operating system to work with multiple types of firmware interface without requiring the operating system to be specifically returned to work with these firmware interfaces. Within the boot environment, startup is controlled using the parameters in boot configuration data BCD stored. The BCD store is contained in a file called BCD registry. The location of this registry depends on the computer's firmware. On BIOS-based operating systems, the BCD registry is stored in the boot BCD directory of the active partitions. On EFI-based operating systems, the BCD registry file is stored on EFI system partitions. Entries in the BCD store identifies the boot manager to use during startup and the specific boot applications available. The default boot manager is the Windows Boot Manager. Windows Boot Manager controls the boot experience and enables you to choose which boot application is run. Boot applications load the specific operating systems or operating system versions. For example, a Windows bootloader's application loads Windows Server 2008. This allows you to put BIOS-based and EFI-based computers in much the same way. Managing startup and boot configurations. You can press F8 during startup of the operating system to access the advanced boot options menus, and then use this menu to select one of several advanced startup modes, including safe mode, enable boot logins, and disable driver signature enforcement. Although this advanced mode temporarily modifies the way the operating system starts to help you diagnose and resolve problems, they don't make permanent changes to the boot configurations or to the BCD storage. Other tools you can use to modify the boot configuration and manage the BCD stores include the startup and recovery dialog box, the system configuration utilities, and the BCD editors. The sections that follow discuss how these tools are used. Manage startup and recovery options. The startup and recovery dialog box controls the basic options for the operating system during startup. You can use these options to set the default operating systems, the time to display the list of available operating systems, and the time to display recovery options when needed. Whether you boot a computer to different operating systems or not, you'll want to optimize these settings to reduce the wait time during startup, and in this way speed up the startup process. You can access the startup and recovery dialog box by completing the following steps. First, in Control Panel, System and Maintenance, click System to access the system windows. And second, in the system windows, click Advanced System Settings under Tasks in the left pane. This displays the system's properties dialog box. Third, on the Advanced tab of System Properties dialog box, click Settings under Startup and Recovery. Fourth, on a computer with multiple operating systems, use the default operating system list to specify the operating system that you want to start by default. Fifth, set a timeout interval for operating system list by selecting the time to display list of operating systems checkbox, and specifying a timeout in seconds in the field provided. To speed up the startup process, you might want to use a value of 5 seconds. 6. Set a timeout interval for the recovery options list by selecting the time to display recovery options when needed checkbox, and specifying a timeout in seconds in the field provided. Again, to speed up the startup process, you might want to use a value of 5 seconds. 7. Click OK to save your settings. Managing system boot configurations. The system configuration utilities msconfig.exe allows you to fine-tune the way a computer starts. Typically, you will use this utility during troubleshootings and diagnostics. For example, as part of troubleshooting, you can configure the computers to use a diagnostic startup when only basic device and services are loaded. The system configuration utility is available on the Administrative Tools menu. You can also start a system configuration utility by clicking Start, Typing, msconfig.exe in the search box and pressing enter. As shown in figures, this utility has a series of tabs with options. The general tabs options allow you to configure the way startup works and are where you should start your troubleshooting and diagnostics. Using these options, you can choose to perform a normal startup, diagnostic startup, or selective startup. After you restart your computer and resolve any problems, access the system configuration utility again. Select Normal Startup on the General tab, and then click OK. The Boot tab options, shown in figures, allow you to control the way the individual startup-related processes work. You can configure the computer to start in one of various safe boot modes and set additional options such as no GUI boot. If after troubleshooting you find that you want to keep these settings, and you can select Make All Boot Settings Permanent checkbox to save the settings to the boot configuration startup entry. Clicking the Advanced Options buttons on the Boot tab displays the Boot Advanced Options dialog box shown in figures. In addition to being able to log PCI, detect the correct HAL, and enable debugging, you can use the advanced options to specify the number of processors the operating system should use. You should use these options when you suspect there is a problem with additional processors you have installed in the servers, and you want to pinpoint which processors and are possibly causing startup problems. Consider the following scenarios: a server shipped with 2 processors, and you installed 2 additional processors. Later, you find that you cannot start the servers. You could eliminate the new processors as the potential cause by limiting the computers to 2 processors. Specify the maximum amount of memory the operating system should use. You should use these options when you suspect there is a problem with additional memory you have installed in the server. If you suspect services installed on the computers are causing startup problems, and you can quickly determine this by choosing a diagnostic or selective startup on the General tab. After you have identified that services are indeed causing startup problems, you can temporarily disable services using the Services tab options, and then reboot to see if the problem goes away. If the problem no longer appeared, you might have pinpointed it, and you can then permanently disable the service or check with the service vendor to see if an updated executable is available for the service. As shown in figure, you disable a service by clicking the related checkbox on the Services tab.